Hello everybody, this is Mr. Kusaj again, and this is part 2 of lesson 1-2. So we're still working with uh, analyzing graphs. So now we want to talk about symmetry of graphs. Before we can talk about symmetry of graphs, do you remember the difference between line symmetry and point symmetry? So if you had some shape and you can draw a line such that left and right, both sides are mirror images of each other. In other words, if you can flip it over and get the same shape back, that's called line symmetry. When you can flip it and get the same exact shape. Sometimes you can turn it on a point, circular, just turn it around, okay? And if you keep turning this, you'll get the same exact shape. If you go half circle, right? If you go half circle, that's called point symmetry, when you turn it and get the same shape back. Well, we use that in graphs as well. So here's a graph. Now I did these free-handed. So I meant it to be symmetrical, right? So if you look at it, it's symmetrical with the x-axis, right? So we say it has symmetry on the x-axis. This one does. So we can see that. But if we want to test it, then we need to look at the equation that goes with this. And we'll do this later when we get to the example. Just write this down. But the way you test it is you replace y with negative y, and you're going to get the original equation back. You'll see that in action when we get to the example. Let me just show you the three possible symmetries. So if you're symmetrical to the y-axis, right? If you're symmetrical to the y-axis, you can see this is symmetrical to the y-axis. And you want to test it, then you use the equation for that. We don't have the equation right now. This is just the graph. We'll replace the x with negative x, and then we should get the original equation. Okay? And this last symmetry is not symmetrical with the y-axis, right? So if you flip it over, you don't get the same thing back. This will be on the left and this will be on the right. That's not the same thing. But if you turn it around the center, right, you're going to get the same thing back. So this is symmetry on the origin, right? The center, the origin. Okay? And the way we test that is to replace both the y with negative y and the x with negative x, and then you should get the original equation back. So I keep saying replace and get the original equation back. What does that mean? It's actually quite simple. So we want to test for symmetry on the x-axis. Okay, so here's my graph. Yep, it looks symmetrical, but is it really? Let's test it. Here's the equation. Okay, so what am I supposed to do to test it? I'm supposed to replace one of them, I forgot now, one of them with the negative. Either x with the negative x or y with the negative y. What do I replace? The negative y for the y. So where you have a y, I'm going to put a negative y there. Now look what happens. Negative y squared, negative squared is positive, so you get positive y squared. So look, even though we replace it with negative y, I still get the original equation. This proves it passes the test for symmetry on the x-axis. So when you want to test for symmetry on the x-axis, you replace the y with negative y. When you want to test for symmetry on the y-axis, you do the negative x for the x. And then here, this try problem that you're going to do, you're going to test for symmetry on the origin. which means you're going to replace both of them with the negative. Put negative x here, negative y there, and simplify, and you should get the original equation. Okay? Work on it right in this area here. Okay. Now, the final thing we want to talk about in this section is even and odd functions. Yes, functions can be even or odd. So, the way we check is, if it's even, then if you replace the x with negative x, then it's going to come out to the original, which means none of the signs change. Right? But if you plug in the negative x and you get negative the whole thing, all the signs change, then it's an odd function. So if none of the signs change after you do this, we call that even. If all the signs change, we call that odd. What about if only some of the signs change and some don't? Well, then it's neither even nor odd. Okay? Let's look at an example. I got two examples here. The first one. Is this even or odd? X to the third minus 2x. Well, let's plug in negative x in both of them and see what we get. Right? We're going to find f of negative x. So I plug in negative x here and negative x here. Isn't that what I did? Now look what happens. Negative to the third power is still negative, right? Negative times negative times negative. Negative to the third power is still negative. X to the third is x to the third. So that stays the same. And then negative times negative is positive. So this becomes positive 2x. Compare it to the original. Notice that all the signs changed. Positive, negative, negative, positive. They all changed. There were only two signs. They all changed. So since they all change, then this is odd. This function is odd. I checked it. Now let's check another one. This one says f of x is equal to x to the fourth plus 2. So now I'm going to find f of negative x and see what happens. Are all the signs going to change? Are all the signs going to stay the same? Let's find out. So x to the fourth becomes negative x, quantity 4, and the 2 just stays as the 2, right? So we know that x to the fourth power, negative to the fourth power is positive, right? Negative to an even power is positive. So the negative goes away, and we just left with x to the fourth, plus 2 we didn't touch, so compare it to the original. Nothing changed, right? Exactly the same thing. No sign changes. So that means it's even. Okay? So I got one try problem for you. So the way we check to see if it's odd or even is to find f of negative x. In other words, put negative x here, here, and here, and simplify and see what you get. You're either going to get the same exact thing with no sign change, or all the signs are going to change, right? This becomes negative, this becomes positive, this becomes negative. Let's see what you get. Okay, that's it. This was way shorter, so we're finished with 1, 2. I'll see you all Tuesday or Wednesday. I shouldn't say that. I'll see you in the next class. All right.